All right, so we're going to take a quick look at a few questions here. The mini quiz slash checkup bit and mini quiz 3. I'm just going to go through the key really quickly, and then I'll work some examples for mini quiz 2. So here we go. We've got Floyd driving down the highway, 25 meters per second. In order to slow down for a deer, he accelerates at a rate of negative 3.50 meters per second squared for 4.25 seconds. He is not obviously terribly worried about this deer, given that he is timing and measuring his rate of acceleration. However, that all being said, we're looking for his final speed. So we're really looking here for V2. Now, I've gone from my original formula here to the completely rearranged version here. What we did here to do this, of course, is we multiply both sides by t, and that ends up with a times t is equal to v2 minus v1, and then we're going to add v1 to both sides, which leaves us with this here. Plugging all our numbers into where they belong, his final speed was 10.1 meters per second. Moving along, Gerard throws a ball. It accelerates from rest to a final speed of 35 meters per second in 0.540 seconds. What was its acceleration? So remembering here that rest is just 0. V2 then is 35 meters per second. V1 was 0. 0.540 seconds is our time, and 64.8 meters per second squared was our acceleration. Howie is driving down the highway at a speed of 28 meters per second. He accelerates at a rate of 1.50 meters per second squared as he speeds up to pass someone and ends up at a speed of 34.5 meters per second as he passes them. How long did this take? All right, so here I've taken the original formula, which you can still see up here, rearranged it. Basically, I multiplied both sides by t, and then I divided both sides by a. And so t is equal to v2 minus v1, all divided by a. V1 is this 28, that was his original speed. V2, that's 34.5, and acceleration is 1.50. And working through the equation, let's go, we end up with 4.33 seconds. All right, we're going to move on to our next one in just a moment here. All right, this is the one we're going to work through some examples real quick. So acceleration mini quiz 2. We've got Ignotus is pitching a baseball, is what it should read. Apparently grammar was bad when this question was designed. Anyways, we figure out what's going on because we're not worrying about the English language at this point. Anyways, ball accelerates from rest. This is our V1. Until it leaves his hand. If the ball leaves his hand at this speed, this is our V2. And it accelerates at that rate. For how long was it accelerating? All right. So in this case, again, we start with our regular formula. A equals V2 minus V1 over T. I'm going to multiply both sides by T because I eventually want to get how long. That's going to be T. That's what I want to know. So I'm going to multiply both sides by T. That'll get rid of the t on the bottom of the fraction on the right-hand side. And then I want t by itself, so I'm going to divide both sides by a. Basically, the a and the t, as you can see, are switching places. Mathematically, this is how we did it. And so t is equal to v2 minus v1 over a. T then is equal to, so V2 was 43.6. Meters per second. minus 0, that's easy. It's that rest bit. All divided by 36.0 meters per second squared. And we end up with our time is equal to 43.6 minus 0, which I can do in my head, which is just 43.6 divided by 36, and 1.21111111111, and so on. But looking here to significant digits, it's going to have 3 significant digits, so 1.21. The next digit would be a 1. That is low enough that it will round down to just 1.21. And our units are going to be seconds. Lovely. All right, moving on. A baseball player. It's a baseball. It was moving toward his bat at 40 meters per second and leaves the bat moving at 65 meters per second in the other direction. All right, so here we have to be a little bit careful. This is going to be some vector stuff. And here we're going to say it's coming towards his bat at, well, 40 meters per second and 65 in the other direction. We are going to say that away from the plate is positive, which means that V1 is going to be this one, and it's going to be negative. So towards the plate is negative, away is positive. This is V1. This is V2. It is positive. V1 is negative. So this is a positive number. This is our time. It is obviously positive, and it's also scalar. And we want to know acceleration. So in this case here, formula is nice. It doesn't have to get reorganized. V2 minus V1 all divided by time. We have to just be a little bit careful here. Now, I should really be being careful with vectors here, because in this case, this is, again, the direction actually matters. We're going to use the positive for going away from the plate, and negative for towards the plate. So V2, that's this positive number, so V2 is, this is our positive 65 meters per second. And now we're going to subtract V1. Now remember, V1 is negative, so this is going to be minus negative 40.0. And if we think back to like grade 7 math, when you first learned a little bit about integers, you're going to hopefully recall that minus a negative means we're really just adding it. And so this is going to be divided by here 0.00120 seconds. Everything has 3 significant digits, so that's going to mean something when I come to my answer. All right, 65 meters per second minus negative 40 is 105, and that should make sense, right? Because really there's a 105 meter per second change in the velocity. Right, it's going 40 meters per second one way, and it leaves at 65 the other way. And if this were the case, this ball is undergoing some serious acceleration, but only for obviously a very brief amount of time. 8.75 times 10 to the 4th meters per second squared. Notice that that is positive. So what direction is that acceleration? The direction of that acceleration is away from the plate, which also should make sense. All right, moving on to number 3. So here, the maximum acceleration for an object that is falling towards the Earth is that. Oh, that's our acceleration. Note that it is negative. That means it's down. It's falling down. If a person pushes themselves downward at an initial speed of 2.05 meters per second, downwards, initial speed, that's going to be negative, and this is going to be my V1. How long do they have to fall before they reach a speed of 100 kilometers per hour? This is our V2, but this is in meters per second. This is in kilometers per hour. One more thing that I didn't just mention. This is, of course, also going to be negative. So we have to change this negative 100 kilometers per hour into meters per second. So the long way, of course, is what we've looked at. We're really just going to be dividing by 3.6, but if you want to see the long way, here it is. I'm going to get rid of kilometers, so we put meters on the top, and the one we want to get rid of, the kilometers, on the bottom. Say, well, there is 1,000 meters in 1 kilometer. And if we look at this again, we want to get rid of hours, so put them on the top, and we want seconds on the bottom. 1 hour is 3,600 seconds. And of course, we do all of the math here, and we end up with our V2 equaling negative 27.7 repeating meters per second. And now we're just looking for time. Okay, we've done this formula before, but I'll just show the starting formula up here. A equals V2 minus V1 all over T. We want T, so we're going to multiply both sides by T times T. And we want to get rid of the A, so we're going to divide by A. So these T's go away, these A's go away. I got to divide the other side by A yet too. And I'm left with my formula of time is equal to V2 minus V1 all over A. T then is equal to my V2 is negative 27.7 repeating. The trick to this question, of course, is kind of a twofold thing. Number one, we don't want to actually round this 27.7 repeating right away. We want to just leave lots of sevens in our calculator. That's going to actually make our whole answer in the end a little bit better. Minus, here we've got negative 2.05. So there's really two tricks to this. Number one, make sure you change your kilometers per hour into meters per second. And the second trick is to remember that it's downwards with a speed of 2.05, so that's negative, and speed of negative 100 kilometers an hour, because that's downward as well. So this actually, we should be looking at this, and this is our vector form of the equation. All right, and this is all divided by negative 9.81. Right, and so we do a bit of calculator work here. If you're doing it all at once, make sure you put all of this stuff that's on the top in brackets. Or you do the top stuff first, negative 27.7 repeating, minus negative 2.05, hit enter, and then take your answer and divide by negative 9.81. Either way is going to work, but just if you're doing it all at once, make sure you do use the brackets on the top. And once we've worked that all through, our time is going to be 2.62 seconds. Calculator, of course, spits out like 2.6226, but so 2.62, the next one is a 2, so this rounds to just 2.62 seconds. All right, there's our answer. Lovely. All right, And then this takes us on to the mini quiz 3, where I've done the work for you already. So number 1, Malcolm's driving down the highway at a speed of 95 kilometers per hour. He takes 12 seconds. That's my time. He gradually slows down to 50 kilometers per hour. What's his rate of acceleration? So V2 is our 50. We have to change that into meters per second. I've done that for you here. V1, that's our 95. Again, change to meters per second. 13.8 minus 26.38. By 12, we end up with negative 1.0 meters per second squared. Right. Nina throws a brick toward a soft wall. It slows from 12 meters per second to rest. If it accelerates to a stop at a rate of 15.5 meters per second squared, how long did it take? Well, we've got V1 is 12, V2 is 0. Acceleration is negative because that's slowing down, so negative 15.5. And away we go. 0 minus 12 divided by negative 15.5. The time works out to be positive because negative divided by a negative is a positive. And it takes her 0.774 seconds. Which takes the ball, not Nina. Let's not throw Nina against the soft wall. A car is traveling at 21.5 meters per second. If it accelerates at that rate, 0.354 meters per second squared for 45.0 seconds, what will its final speed be? So here we're solving for V2. We've done this work already. I'm not going to work through it again. And it's going to basically be 0.354 meters per second squared times 45.0 meters per second, or sorry, 45.0 seconds plus 21.5, and we end up with a final speed of 37.4 meters per second. All right, have fun. Good luck on your quiz this afternoon.